Hey class, we're going to go through section 1.3, data collection and experimental design. So these first 6 bullet points are just the key things that go into a statistical study. So of course the first thing we would want to do is identify what we're studying, identify the variables. And then we would want to collect a detailed plan or develop a detailed plan for collecting the data. So if we're using a sample, which is usually the case, make sure the sample is representative of the population. A lot of this section is going to be dedicated to that, right? Making sure that that happens so that our study is valid. And then, of course, we've got to collect the data, describe the data. Now, this one, we're going to do a lot from, that'll be a lot of chapter 2 right there, right? Using descriptive statistics. And then we've got to interpret the data, and a lot of that is going to be the second half of the class where we're doing confidence intervals and hypothesis tests and all those inferential things, right? So we'll get to that, and then identify any possible errors. Okay, so some of the highlights from this chapter, we get to the first thing, a census, right? So when you see that term, you probably have seen it before. That's a count or a measure of an entire population. So oftentimes that's not possible. So it's common to do a sample, right? Especially if you're studying, like, say, the entire United States population, right? We're not going to be able to involve everyone in the entire U.S., so we would take a representative sample. Okay, so that gets us to some sampling techniques, and this is the first major thing that we're going to look at in this section. There are 5 of them listed here, so let's go through each one and discuss them a little bit. As an example, as I go through these, I'm going to be thinking of, instead of people, let's just talk about apples, right? Let's say we have this large vat of apples, and we want to take a sample, right? What would be a way to get a sample? Okay, so, and again, let's say we have like 3 types of apples, right? There's lots of sizes, but there's green, there's red, there's yellow. Okay, anyway, a simple random sample, it's a sample when every possible sample of the same size has the same chance of being selected, right? So usually this is done by like random number generation, right? Let's say you have 1,000 apples. Maybe we'll assign each apple a number and then randomly select, say, 10 numbers if we want a sample of 10, right? That way every apple has a chance to be chosen. You don't divide them up originally, you just, keep all 1,000, randomly choose 10, right? That's the simple random, right? That's typically, what you would think of when you do a random sample. Just randomly choose 10, right? It's kind of like picking numbers out of a hat kind of thing. Now, some more advanced things would be something like stratified sample. Okay, so this one, members of the population are divided into 2 or more subsets first, right? And then a sample is selected from each subset. Right? So here, maybe we have a situation where we will take the 3 colors of apples, right? So we have the red apples, the green, and the yellow, right? Separate them out first, and then pick a few from each color, right? This method ensures that your sample is representative of all of the colors of apples, right? You'll have some red, some green, some yellow, right? Whereas in that first one, right, if you just choose 10, maybe you get a sample that just has red apples, right? You didn't get any green or yellow. So this one ensures that if there is a characteristic of interest, we get all those categories represented. Okay, so that's stratified. Could also be age, gender, ethnicity, things like that. Now cluster, the next one down, oftentimes is confused with the stratified. So these are the 2 that are similar but different. Because cluster, you do have groups as well, right? But the population falls into naturally occurring subgroups. So the key is naturally occurring. In other words, you know, like in the apple example, I guess maybe naturally occurring, there's already a bunch of vats of apples in the factory, right? So the apples have been picked and then just put in these big vats randomly, right? So maybe you have just a bunch of vats of apples, right? And what you're assuming with cluster is that each one of these vats is already pretty much representative of the population as a whole, right? So for simplicity, let's just take one or two of these vats or buckets of apples, right? And call that our sample, right? So there's the big difference, right? The first one, stratified, you put them into groups based on characteristics and then take from each one, right? Cluster, there's already naturally occurring groups. And then if you assume that all of those groups are representative of the population, then it makes sense for simplicity. Let's just take as many as we need, 2, 3, 1, whatever you want, okay? Okay, so hopefully that makes some sense. We'll see some more examples in a minute. So let's keep going. The next one is systematic. That one sticks out. This one's nice. Just members are ordered in some way, and then you just select a number and take every, say, for example, fifth subject, right? So in the apple example, right, as they're coming down the conveyor belt, right, you're just going to count them and then choose every fifth one or whatever number makes sense till you get the size you want, right? So that would be a systematic approach. And then finally, convenient sample consists just of the population that are easy to get, right? So I don't know, in the apple example, just the ones that are closest to you, right? Or just this one tree that's right here that has all these apples, I'll just conveniently choose this one. Okay, so we'll see some more examples that are just not of apples, but of other things. But those are the 5 main techniques. And then bias sample down here is just one that doesn't represent the population. Oftentimes convenience doesn't. So it's a common type of bias sampling. The others are all pretty good. Okay. There's also a video that I'll put in your homework that has a little bit more information on these 5 and also some pros and cons of each one. So that's pretty helpful too. It's got some cool animation. I think it talks about apples too. All right. Anyway, let's move on to the next page, page 11. So just some practice here. If you want to play along, try to answer before I do it. That's probably a pretty good idea. You can pause and try them out. But that first one, okay, so we have a county, rural population. Researcher randomly selects 500 adults age 65 or older, and then they randomly select 500 adults age 65 or older from the country's urban population. All right, so they take 500 from rural and 500 from urban. So notice here the subjects are divided into categories first based on a characteristic. So if you're thinking stratified, you're good. Right? Okay. Divided into groups and then chosen at random from each group. Okay. How about number 2? 100 students are assigned a number. Oh, as soon as you see that assigned a number, right? And then computer picking, right? We know that. That's simple random. Okay. How about the next one? You place a link to a survey at the ARC homepage. Those who want to participate. Okay, there's the key there, right? Just those who want to. Are you thinking convenience? Because you're right. That would be a convenience. Right? Oftentimes, voluntary surveys are a good example of convenience sampling. Funny thing is, it's the thing that's used most often, right? It's just hard to collect data. It's hard to force people to take surveys. So oftentimes you're taking volunteers. Every 10th person entering them all. Yep, you know that one. There's the systematic approach. So you're kind of looking for keywords here on these, right? You see that every 10th or every nth. subject. You're gonna go systematic on that. Okay, how about 5? Southwest Airlines wants to know if their customers are satisfied. They select 5 flights on a given day. All right, so they select 5 and ask everyone on the flight. Okay, so notice that that's an example of a cluster, right? Because you have all these flights, right? I guess these are my flights. I don't know why I'm doing circles for flights, but that's easy. And then so there's all these flights, and what you're assuming is that each flight has a pretty representative population, or representative sample of the population of customers. So it makes sense just to let's just choose these first 5 or whichever 5 you want and ask everybody from those 5, right? That's the cluster idea, okay? Random digit dialing, that's a technique that's used quite a bit in like political polls and that sort of thing, but that's simple random. Right? It's kind of like assigning a number. Right. Oops, I forgot to say that this is cluster. I just drew it, but I didn't write it. Okay, if you want to determine the average age of 115 residents, okay, here's a little bit of a different one. Do you want to do a census or sampling? And we have 115. So, okay, I mean, if you can get everyone, a census is way better, right? Because you're not estimating your statistics, right? You're going to get parameters that way. So if you just got to look at that number, I don't know, is that reasonable to ask 115 people? I'd say yeah. I mean, I'd probably go with the census on that one, unless you're really short on time. So I would say that third one maybe, right? The study would use a census because the population is small enough for it to be practical, right? Yeah, I like that. Okay. What about if you want to determine the average commute time for ARC students? Average commute time for ARC students. Okay, well, again, I mean, is it practical to ask everyone? I kind of think no on that one because there's lots of ARC students, right? So I'm going to go sampling technique on that one, right? I don't know how many students are there, 40,000 or something, 30, 20? Way too many for it to be practical. Right? All right, moving on. On the next page, we've got 2 main types of statistical studies. Okay, there's observational studies. Those are things like surveys, that sort of thing, right? Just researcher observes, but no changing conditions. So the key there is does not change existing conditions. So survey is often the most common thing for an observational study. Right. Whereas experiment's a little bit more involved, right? You apply a treatment before observing responses. In a typical experiment, you have 2 groups, a treatment group who receives the treatment and then the control group who doesn't. So that way you can compare them to see what effect this treatment has. Okay, so let's do some examples. Observation or experiment? I'll just put O or E so I don't have to write out the long words. Save some time on this video. How about number 9? In a survey. Oh, dang, right there. Survey. Well, observation, right? No treatment is being applied. We're just gathering information, things that have already happened. Okay. So for 10, study the effect of music on driving habits. The researcher is applying a treatment. Notice this, right? The researcher had the first 25 listen to rock. Next, right? So there's a treatment being applied. There's some treatment groups. There's a control group, right? That last group. The final 25 listen to no music. So you got your control group. So there's a classic style of an experiment. Right? The next one, researchers are just looking, right? Feeding habits. So there's an example of an observation. Right? And then finally, a footwear company testing a new type of shoe. Half the subjects wear the new design, the other half wear the old design. Right? So it looks like they're applying a treatment. The treatment here is what type of shoe you're going to wear. So there will be an experiment. Okay, so there's some good examples of observation versus experiment. And then some other things that go into designing an experiment, right? So observation is pretty much you do a survey or you just observe. Experiment, there's a lot more that's going to go into it, right? So designing an experiment, there's some key elements, and the key elements are right there: control, random, replicate. Control can be ruined by a variety of factors, so it's important to control influential factors, like, for example, a confounding variable that occurs when the researcher can't tell the difference between the effects. So there's just too many things going on, right? So usually in an experiment, you just want to focus on one variable, change that one variable, right? And then you can see the effect, right? Like, for example, on that one about the shoes, right? All we want to do is just change the shoes, right? If we're also going to change the socks and the shorts, or like do different quarts, right? Or different, too many variables that are going to cloud what you're actually trying to measure, that's a confounding variable. So you want everything to be the same except change the shoes. That's the idea. Okay. Another thing that happens in experiments is the placebo effect. Right, so we're down here. Right? That occurs when a subject reacts favorably to a fake treatment. Right? So just because you're getting the treatment, you think it's going to have a positive effect, right? Oh, I got these new shoes. I play better because I know these shoes are supposed to be better. So it's just a mental thing. Right? It's called the placebo effect. So to minimize that, researchers will do a technique called blinding. Right? Subjects don't know whether they're receiving a treatment or a placebo. They don't know if they're getting the new shoes or the old shoes. Right? And then double blinding, the experimenter doesn't even know, so they don't give off any tells about whether it's better or not. Okay, so little things about controlling an experiment that are pretty cool. And then some more information about experimental design, randomization. So this is the process of, okay, you have your sample, you did a sampling technique, now you got to put your subjects into different treatment groups. Right? How are you going to do that? How are you going to separate them out? Who gets to wear which shoe? Okay, so here's some ideas, right? You can do a completely randomized design, right? So you just, you go there, like kind of assigning numbers type of thing. That would be completely random. Or block design, first divide the subjects with similar characteristics into blocks. So this is a lot like this one here. Uh-oh, what happened? I think my pen turned off. Sorry about that. There we go. That one's a lot like stratified, right? But it's a different name because it's dividing an already established group of subjects into different groups. But it is a lot like stratified. So that just ensures that your two treatment groups are similar in characteristics. And then match pair just means like, maybe you have two subjects that are very similar. One's in the treatment, one's in the control. Right? So that just ensures that your two groups are similar. Yeah. And then replication, just keep doing the experiment under the same conditions. Okay, so finally we got a couple of questions here, and then we'll finish off this video. Just something a little bit about what we're talking about with biased questioning. Right? So this is going back to observational studies. If you're doing a survey, there's a lot goes into like designing good questions in a survey. You don't want to lead the reader or the subjects to answer one way or the other. So here's an example. Number 13, why is drinking beer bad for you? All right, what do you think? Is that a biased question? Well, notice it's already leading the reader to think something about beer, right? Whether or not it's true, you're still leading them to believe it, right? So it does seem a little bit biased, right? There's probably a better way we can ask this question without involving bias towards the subject, right, and leading them one way or the other. So let's see. Of these 5 choices, which one do you like? Do you think that drinking beer is bad for you? That's still kind of leading, right? Why is drinking beer good for you? Here we go. How about, how do you think drinking beer affects your health? there's the winner, right? That seems to be non-biased. Okay. Okay, and then the final question, I'm going to leave that one up to you. And this is one takes everything from chapter 1 and puts it into one question. So typically, if I did this in class, the students would get into groups and discuss some different ways to design this experiment. So for the online class, what you're going to do is write down some things and do a discussion post. So this is your discussion post number 2. You're going to write your original post, how you would design the experiment, and then respond to 2 other students from their posts. Okay, so hope you enjoyed section 1.3. Do that homework right away. Hopefully it matches what we've done in this video, and I'll see you on the next one for chapter 2. All right.